Hello everyone. Today we are going to discuss about the types of the electric field. Already we are familiar with so many types of the field, but here the concept of the electric field plays a very important role. So let us we understand the types of the electric field. It is categorized into three important categories, that is uniform electric field, non-uniform electric field and radial electric field. Let us we understand what actually uniform electric field is. As the word indicate, uniform electric field, already we are familiar, that is the field around the charge where its influence can be observed, and when this influence is similar or we can say same, that is the concept of uniform electric field. When magnitude as well as the direction of the electric field is same at all the points in the field, that is under the category of uniform electric field. So in this particular diagram you can see that is how the uniform electric field has to be observed. That is, you can see it, the lines, they are moving from one direction to the another, which are equally spaced, they are moving. It's shown in the particular diagram. This is the example of uniform electric field. Now come to the second one, that is non-uniform electric field. When magnitude and direction of the electric field intensity are different at different points in the field, that is, you can see from the diagram, that is at the ends from where the electric fields are originated and where it completes its path, it has been found from the diagram. That is, there is a variations in the electric field directions at the different points if we observe very minutely. Let us we continue. This is the part of non-uniform electric field. Come to the third point, that is radial electric field. Radial words indicate the field in a directed towards or away from the same fixed point. Here the positive charge is at the center, suppose, and electric field is directed out from this one. So this is the representation of radial electric field, the field which is directed towards or away from the fixed charge. So it may be the positive charge, it may be the negative charge. So this is the category of radial electric field. So let us we understand about the concept of electric field lines, what actually these field lines are. It is the path described by a small positive charge placed in electric field. The lines of the force due to different electric charges. That is, from this diagram it is clear that you can see the positive charge is at the center and the direction of the electric field lines are in the outward. That is, the lines of the force due to different electric charges. This particular isolated charge shows the electric field which is spread out not only in all the direction but just like a sphere. When a particular charge at a point, it shows the electric field lines in one direction, in another direction, in another direction, in all the directions, and when we see all this, it is a three-dimensional structure just like a spherical. In the second one, this is we call the part of isolated positive charge, and if the same concept with the isolated negative charge, then what happen? Electric field lines are pointing to the charge, that is the direction is opposite to that of the positive. They are start meeting at a one point. So this is again as a part of sign convention, as a part of the isolated charge, how it shows uniformity in the electric field lines. Let us we continue with the isolated charges, but they are now positive and negative. That is, sometimes the different charges. In this particular diagram, the two charges are of similar nature. That is, both they are positive. So when both the charges are positive, you can see at the point when the two charges, in between the two charges, the value of the electric field is very, very small. Even it has been observed that we are getting a null point in between these two charges. Here the electric field is weak. But as compared to the outside, where the electric field lines are emerging outward directions. At these points, electric field is stronger as compared to between the two charges. So this is the representation of the electric field lines when the two charges are of similar nature. That is a pair of like charges you can see. Come to the second one, when the two charges are of opposite nature. Here we can see the electric field lines, they originated with the red color, it is mentioned they originated from positive and end at the other points. So from these 2 points it is very much clear. That is also the properties of the electric field lines. From positive charge, electric fields are come out, from in the negative charge they start meeting. So properties are also followed. Secondly, when the two charges which comes in contact to each other, they are very close to each other, how the force or the electric field lines has to be mentioned, how to be represented. So they originate from positive and end at negative. Rest of the things we will discuss when we are comes to the important properties of the electric field lines. So this is a pair of unlike charges. And here the plane conductor carrying the equivalent opposite charges. So these two sheets from where the positive and negative charges are mentioned, and from here we can see how the electric field lines has to be observed. Let us continue the properties of the electric field lines. They start from the positive and end at the negative. As already we have seen in the diagram that how the electric field electric field lines starts from a positive and end at the negative. You can see from the diagram we are mentioning the positive and negative charge, and you can see again I am showing you can see how the positive and negative electric field lines, they start from positive and they close at the negative point. So positive to negative, it is shown in the diagram very beautifully. Come to the second point, that is they always originate or terminate at right angle to the surface of the charge. In case of the positive, they start making this particular angle when we do all these experimentally. Come to the next property, they do not pass through a conductor. It means all this because we are dealing with the electrostatic charges are reside on the surface of the conductor, so they do not pass through the conductor. This is a very important point. They never intersect each other. Electric field lines, they never intersect each other, because at the point of intersection, if they meet, then what happens? Electric field lines shows two directions. Although electric field is a vector quantity, at one point, as we know that the property of the vector, it doesn't show the two directions. So similar case with the electric field lines. That is why they never intersect each other. Let us continue the properties of the electric field. The relative closeness of the lines of the force gives the idea about the strength of the electric field in that region. It means if electric field lines are very close to one another, then what happens? Obviously the electric field lines are stronger, and if they are farther from each other, electric field lines are not as much stronger as in the previous case. So in this particular diagram you can see between the two charges, positive and negative, the closeness of the electric field lines are more. So that is why if the charges are opposite in nature, so we are getting stronger electric field within the region. In this particular, which is I'm mentioning with the red circle, in this particular region, so they continue. This is the next property. They contract longitudinally, that is lengthwise. This explains the property of attraction. You can see here is the positive, here is the negative. How beautifully in this particular diagram. Let's see, let's have enjoy of this one. Yes, that is they contract longitudinally. I'm again showing this. You can see again it. They contract longitudinally, that is lengthwise, which explain the concept of attraction. This is the beautiful explanation how the electric field lines, they start from positive and they end at negative. So this is the basic properties of all these properties are focused on the electric field lines. They exert a lateral pressure on each other, and this explains the concept of repulsion. So how the concept of attraction and repulsion to be mentioned. Now come to the repulsion, let us discuss. Here is the charge, here is again of similar charge. So we know that when the two similar charges are closer to each other, so between the two charges we are getting a force of repulsion. So how the lateral pressures on each other, how they exert a pressure on one another, you can see very beautiful in this diagram. Yes, again we can see. Yes, so because of this lateral pressure on each other, because of the similar nature, this explains the concept of repulsion. Let us have a reflection what we have understood till now. Question number 1. The electric lines of force is the path followed by a free dash number 1 positive charge, number 2 negative charge, number 3 arbitrary charge, and number 4 zero charge. So it is the path followed by a, yes, the correct option is positive charge. Come to the next one. Which type of the electric field is present in an isolated point charge? Option radial, circular, elliptical, and the hyperbolic. Yes, the correct option is A, that is radial. Come to the next one. At which angle to the surface of the charge the electric field lines of force always originate and terminate? Options are 30 degree, 45 degree, 60 degree, or 90 degree. Yes, you're correct. The option is 90 degree. Thank you.